everyone, and welcome to today's Gen webinar entitled Gene Writing and Rewriting, the Key to Unlocking Its Full Potential. Our webinar today was made possible through sponsorship from Secura Labs. I'll be your host for today's webinar. I'm Juliana Lemire, Deputy Editor-in-Chief at Genetic Engineering and Biotechnology News, which has been the leading source of information on new tools and technologies within the life sciences industry for over 40 years. So despite its promise, gene writing poses several challenges that must be addressed, including improving cloud resource efficiency, a crucial step to perform large-scale analyses without breaking the bank. Fortunately, bioinformatic tools like Nextflow and Nextflow Tower can help overcome these challenges by making pipelines that make it easy to launch, monitor, and analyze results, saving time at all stages in the data analysis workflow. Our presenters for today's event are going to talk a lot more about this topic in just a few moments. But first, let's meet our presenters for today's event. First, we will hear from Grigoriy Sterin, Senior Principal Engineer at Tessera Therapeutics. Grigoriy will kick off our webinar today with a talk entitled Building Data Platform with Nextflow. Tessera is harnessing mobile genetic elements, or MGEs, to create a gene writing technology using a combination of computational tools and wet lab approaches. In this talk, Grigoriy will share his experiences with how Nextflow helped Tessera build a data platform, discussing how Tessera's data analysis pipeline went from exchanging data using Excel sheets and flash drives to how the company overcame the challenges of building up the infrastructure for processing large-scale data sets with ease. Grigoriy will then hand the webinar over to his co-presenter, Dr. Evan Floden, CEO and co-founder of Secura Labs, who will present his talk entitled Gene Writing and Rewriting with Nextflow and Tower. In it, he will share more information and examples of how some of the Nextflow pipelines introduced by Grigoriy can be used to analyze, for example, RNA-seq and CRISPR-seq data. Now, before we get the webinar underway, I want to remind the audience that we would love to hear from you in our Q&A session that will begin right after the presentation ends. Grigoriy and Evan will be available to answer as many of your questions as they can. So simply type your questions into the Q&A box and hit submit. Okay, with all that said, I will turn things over to Grigoriy, who will get our webinar started.
Today I'm going to talk about how we built our data platform using Nextflow as foundation for this at Tessera. So, as it usually happens in small companies when they start, in the beginning, our data analysis pipeline would have looked like this. So some data came off from the instruments. Scientists would do some preparation with this data, then maybe exchange it with each other using Excel sheets, Smartsheet, maybe even flash drives. And then computational biology team would run the analysis pipelines on the data, using either their laptops for this, or maybe in best case, some EC2 instances in AWS cloud. And then the results would be shared again back with the scientists using the same means like Excel, flash drive, Ignite, and so on. So this approach has obvious drawbacks. It involves many manual steps. It doesn't scale well because of those manual steps. It lacks reproducibility because once the data is produced, it's hard to say where it's stored. And for the same reason, it's hard to trace the particular analysis results from which data were they produced. So what do we want? Which state actually we want to have? The ideal state of the analysis pipelines of the data platform would look like this for us. The data would come from instruments to the cloud directly. The analysis would happen in the cloud. The cloud allows to scale virtually, like indefinitely. We would store data in the cloud so it can be traceable at any point in time. and we would have some convenient way for the scientists to view, search this data, and share it with each other. So the question is, how can we get to this state? And which tools can we use for this? So one of the tools we use is Nextflow. It's a scientific workflow engine, which basically allows you to build data pipelines connecting different tools with each other. And it takes care of moving files, outputs, inputs between the sub-processes of the pipeline. For example, you may have some bash script which does something with the files. It produces, let's say, 1,000 files. And then you want to feed these files into some Python program which you created. And you want to do it in parallel. And Nextflow would allow you to do this. It allows you to do parallelization natively. And it offers the DSL to create your workflows. So when using Nextflow in the organization, it allows us to basically have the unified way to create those analysis pipelines workflows. So this is good, and scientists can use it on their laptops still and which is good to test their pipelines if they work at all, or maybe test them on local data. But still, how can we move to the cloud? And Nextflow perfectly allows to do this because it natively supports AWS Batch. And AWS Batch is a AWS service which allows you to do horizontal scaling of resources in AWS. Basically, you don't need to think about starting EC2 instances to run your workflows because AWS Batch would do it for you. It allows you to create compute environments, and each compute environment is basically a pair of the queue and ECS cluster. So Nextflow can submit its jobs to the batch queue, and they would be executed in the particular ECS cluster, and AWS would take care of spinning up the EC2 instances required for this. And when you do so, you can also store data in AWS S3 buckets. So the data is no longer stored on the local machines. But this still requires some configuration to do. For example, you would still need to create those AWS Batch compute environments. And obviously, we don't want scientists to do this themselves. So there is a tool provided by AWS, which is called AWS Genomics Workflows. And it's basically a set of CloudFormation templates, which allow you to deploy all required resources which you need to run your Nextflow workflows. And it actually supports multiple workflow engines. It supports Cromwell, Nextflow, and I think SnakeMake. But we were mostly interested in Nextflow. So there are several drawbacks in this set of templates. First of all, the permission management is complicated. If you need to access some custom AWS resources from your pipeline, you would need to change the IAM roles in these templates and redeploy the CloudFormation stack, which is not ideal, obviously. Also, there is no support for private Git repositories out of the box. It only supports public repositories, but in our case, we store our code of our workflows in GitLab and private repositories, and we wanted to allow Nextflow to just take code from there. And if you want to have computer environments with different resource configurations, for example, different amounts of CPUs and memory, you would need to deploy these templates multiple times and basically create multiple CloudFormation stacks and then maintain them. So to tackle these issues, we had to fork this project and fix those drawbacks, and then maintain this and keep it in sync with the original version. And another problem with using pure AWS Batch and using AWS Genomics workflows is that scientists have little visibility into what's going on with their workflow, because once you submit it to AWS Batch, it's running in there, but to see the logs, to see if your workflow is failed or what's going on at all, you would need to log in into AWS and navigate to AWS console or use AWS CLI to see what's going on with your batch job, and probably go to CloudWatch logs to see if anything failed and so on. So this is too complicated. So we wanted to have better monitoring and configuration management solution. And here is where Nextflow Tower comes handy. It's a control and monitoring plane for Nextflow, and it has several awesome features. First of all, it allows to launch pipelines directly from UI, because previously, before we had it, you basically had to submit the batch job to start running your Nextflow pipeline, either from AWS CLI or using the AWS console. And monitoring pipeline execution process is simple here, because it takes logs from CloudWatch and shows it to you in the UI. It also has role-based access control, so you can create teams. You can choose which users can submit pipelines, which users can edit those, or who can create compute environments, and so on. And also it has Tower API, which is very useful if you want to integrate Nextflow Tower with third-party tools. So another awesome feature, in my opinion, one of the best features which Tower has is Tower Forge. And it allows you to create and delete compute environments with a few clicks. So basically you can, instead of having this cumbersome AWS Genomics workflows templates, which you have to maintain, you can just pick the environment configuration which you want here using a couple of clicks. You can even use some specific Nextflow features which are, I think, not available otherwise. You can use S3 Fusion drives, you can use Wave containers, you can use EFS or FSX for raster file systems as a working directory, and so on. And it's really cool. You can deploy as many computer environments as you want, and you can pick different ones for different pipelines. But still, now our scientists had the possibility to launch their pipelines, monitor the execution, but we still want to implement more automation. Let's say we want to automatically trigger pipelines when some data arrives to S3. And we can do it. And initially we did this using pure AWS services, using Lambdas, CloudWatch rules, and so on. And as shown in this picture, architecture of such solution may look like this. And it quickly becomes quite complicated. And there is lack of visibility again, because you can check how each separate pipeline ran in Nextflow Tower, but it's hard to monitor what's going on in these lambdas. If you receive some CloudWatch alarm, you still have to go to CloudWatch to check what's going on. Obviously, we could use log aggregation here, but the problem still stays. And so it's also hard to test properly, your triggers and stuff, hard to maintain, and code is spread across different spaces and projects. So this is where Tower API helped us a lot, because we were able to introduce some general purpose workflow engine on top of this. We use Dr, but actually anything like Airflow can be used in here. And it allows you to have the pipeline triggering logic written in simple Python instead of CloudFormation and Lambdas and so on. And it becomes easy to test and maintain and easy to monitor. So we have Dr on top, we have Nextflow, and then we have our actual Nextflow processes executed on AWS batch. So here's how interaction between components here can look like. For example, we can have custom sensors in Dr, which are written in Python. They monitor that some new message arrives to SQSQ. This triggers Dr pipeline, which calls Nextflow API, which triggers some Nextflow pipeline. We wait for its completion, and then from the Dr pipeline, again, we trigger some subsequent Nextflow pipeline using Tower API. And in the end, we can store our results in the database. So obviously, there are several good points here. First of all, we can easily use other systems APIs from Python code. We can call various AWS services, use databases. We can have custom sensors detecting various events and so on. And another tool which we use in our data platform is Quilt. And so it allows us to make data visible, searchable, and actionable for scientists. Basically, it's interface on top on S3, which allows you to group data into packages. It allows sharing data between people by simply sharing a link, and has built-in support for in-browser rendering for various data types like HTML, Jupyter Notebooks, and so on. And it also has built-in search capabilities based on Elasticsearch. And here we can see how it's how all of this connects it together in our pipelines in our platform. We usually detect new data on S3 automatically using our custom sensors. We trigger some Nextflow pipeline using Dr. We wait for Nextflow pipeline completion, trigger next one, and so on. And at each point of time, we store our data on AWS S3, and we also store the packages in Quilt. And this allows us to make the data traceable at any point in time. It allows us to provide the data from each step to scientists, to whomever needs this. And it allows us to store metadata during the execution process in the database, which we do in DynamoDB. And yeah, so here's how Nextflow and Nextflow Tower in particular allowed us to get from the initial state where there were a lot of manual steps to the almost fully automated process for analyzing our data whenever it comes from the instrument. Thank you.
It was really great to hear some of the information there from Grigoriy and from Tessera and all the great work that they're doing with Nextflow and Tower. I'd like to step back a little bit and share a little bit more information on Sakera and how we came about, and then dive into a demo on how you can run some of those similar pipelines of RNA-seq, CRISPR-seq examples onside the Nextflow Tower platform and give you a little bit more hands-on experience with running that. So starting off with a few things on Sakera. So we've been around since about 2018, but the origins of the project date much further back than that. So Sakera was founded by myself and Paolo Di Tommaso. We started Nextflow about 10 years ago now. So I guess the company's been around for about half of that time. And really, and since that time, we've really been growing both the open source community, but also creating products around really helping scientists use open science tools and commercializing them to make it more accessible to a broader community of folks as well. So as I mentioned before, mostly focused on development of Nextflow, but as well as Tower, which is what I'm going to show you the demo of later on. We have around 150 customers all around. So things like large pharmaceutical companies, biotechs, some clinical diagnostics. We're also really involved with the customers involved in deploying this into the cloud. So involved with AWS and Azure and Google, which I'll go into a little bit later on. So starting off with what Sakera is really helping customers do, it's typically dealing with sequencing data. And obviously that's a kind of a big part of some of the work that we showed before. Nextflow itself has been involved, for example, in the pathogen surveillance. This is with regards to the SARS-CoV-2 sequencing. Pipelines were spun up very early on in the pandemic to help with understanding essentially what the variants were doing. Again, large amounts of sequencing, high throughput analysis was there. We have customers like 23andMe. Here's an example of them running their imputation pipeline here. You can see the blue lines is the number of CPUs they're running in a single environment here. So we're looking at 10,000 CPUs there. So very large scale analysis as part of imputation. There's also a big part of it, and this is very much related to the earlier work, which is around personalized medicine. This is some work showing how you can take essentially tumor samples, normal tissue samples, generate and predict neoantigens using machine learning, and then generate personalized therapies with regards to that. And of course, there's a whole bunch of stuff with regards to diagnostics and the typical clinical testing. If we think about how all this story started, well, in all of these pipelines and all of these use cases, you typically have a problem where you've got multiple different steps in a pipeline. You have a lot of samples. These could be typically sequencing samples, so FASTQ samples, and you need to run each of those samples through this pipeline and then be able to run that at scale. And what Nextflow allows you to do is to write those pipelines as well as run them and then eventually share them with colleagues or with folks around the world. The basics of it is it allows you to take existing code, R, Perl, Python, Bash scripts, etc., link those different pieces of code together using the Nextflow syntax. You define the containers or define the dependencies, typically with things like Docker, wrap all of that in a Git repository, and really from there it can be run on any infrastructure. So the kind of key advantage of this, it means that you can develop locally on your laptop. You can spin it up into your cluster if you need, spin it up into the cloud, share it with colleagues who are in different environments. And that in itself has really led to a whole piece around the community. It means the community can work on this whole piece of the pipeline independent of where we run. And I'll show you some examples of what that looks like later on. The success of Nextflow has been really, it's gone very large, particularly in the last couple of years, where we've seen a large piece of the community development. A lot of that has been coming from the NF core community, so there's collections of pipelines, but also continues to grow with around 120,000 downloads a month on top of this. In developing Nextflow, we really realized there's a whole bunch of adjacent problems to Nextflow. So Nextflow primarily focuses on this batch computation. It's really this high throughput orchestration piece. And we realize there's a whole bunch of other problems associated with that. So whether that's development of your workflows or development of the underlying tools in those workflows, connecting in with the data, and the data management is a really key piece of that. The batch computation I mentioned with Nextflow, interactivity, things like notebooks, our studio environments, VS Code environments, as well as the reporting and the standardized features that you'd expect to get from an enterprise piece of software. So what Nextflow's Tower is really trying to do is just be this collaborative platform which ties all of these things together. And I'll show some sort of demo on what that looks like. Why are people using Tower? So why has there been a big push for this? Well, of course, as we move to the cloud, and as many people move to the cloud, understanding your cloud costs is really key and being able to optimize for that. There's also a whole bunch of tasks that people are typically doing from the command line. It's much better if you can run those things in an automated way, have them from actions or from an API, remove a lot of the human in the loop, which is sometimes required. Also, there's key pieces around collaboration, reproducibility. Nextflow is obviously key with that with regards to using containers and standardized infrastructure, having your infrastructure as code, as well as the setting up of the infrastructure itself. So how you can actually do that across HPC and cloud. In this case, kind of the big drivers for why folks are using Tower here. On the cost saving piece, this is something which has become very significant, particularly as people start to scale up those pipelines. We have customers with several $1 million AWS bills per month. As part of that, though, we've really been working with many of those to really save those costs. Some of these come from spot instances, so being able to use those spot instances can save you significant amounts. We've got some work which we've been doing around automated resource optimization, so knowing exactly for each task what's the right amount of memory, CPU to require. The pipeline resume functionality with Nextflow is obviously key for this, as well as just having visibility on those costs, knowing exactly what's been run from a particular organization or a particular workspace or a particular pipeline, and having that feed through all the way through to the piece. I also like to mention that the way that we run this, it all runs in your own environment. So the data stays completely within inside your cloud. Obviously work with all the major cloud providers for doing this, or if you're on-prem, that works as well. And this is kind of a key piece to making the system very scalable, but also very secure for what you do this. And a little bit like Nextflow, Tower can be installed in any environment as well. I'll show you that now. So I'll just jump through now onto a quick demo of Tower. We have a hosted version of this, which is what I'm showing you here. So this is the hosted version at tower.nf. When you sign into here, you can add in your own credentials. So if you have OpenID Connect or whatever system your organization is using, a user would simply log in here. Here you can see I've got a collection of pipelines which are available. These are Nextflow pipelines, simply a collection of a repository combined with some compute. As a user, you may be coming through and often starting with the data. So starting with the sample sheet that you have. Here are some example sample sheets that we have. These are typically CSV files or TSV files with sample IDs, locations of some files, as well as some metadata here. I could upload this. Again, I'm showing you from the user interface, but this could be done primarily from API. A user who's coming in who's maybe launched these pipelines often. Let's think about some of the work we saw before. A lot of RNA-seq work goes on here. So I can launch this RNA-seq pipeline. As a workflow developer, I can define exactly what this user interface looks like. But in this case here, I may want to add some labels to it. So maybe we wish to know for example, that we're running here with yeast, and that we want to run, for example, with some research lines. I can find the data sets I mentioned before, so I can go search for the data samples, and then maybe I wish to choose some information on where I want to have those output files. That's typically enough to get launched for now. This is a production pipeline though, so there's many different options which are available. And you can make this as complicated or as simple as you require. In this case here, I've got all of the options. So for example, if I wish to have drop-downs here, you can see here, I can choose the drop-down with regards to the UMI tools grouping method. If I wish to split these files, if I wish to remove the ribosomal RNA, simply make a selection there, and then kick off that pipeline. And now what's going to take place is Tower is going to submit the Nextflow task, Nextflow job, into the cluster of my choosing, and I can then start monitoring it, steering the results, and seeing what's possible here. So here's one I just kicked off before. I can jump into that pipeline, and now I can monitor it. You can see under the hood, I've got Nextflow running here. I've got parameters, configuration, any data sets I've used, as well as the execution log. If you're familiar with Nextflow, this is just a kind of a log of those files as they come out of there. I can also follow the status of these task slides. You can see that these are updating as we go through. Each task is a container running into the execution environment of my choosing, and this really provides visibility on those cloud resources. I can see the status across these different processes. Again, it's a pretty complex pipeline here, so I've got a lot of different steps. I can also see aggregate statistics on time, CPU, memory, as well as things like the cost. So there's a database of all the costs across all the cloud providers in the different regions which provide you that. Here you can see the load, so how many CPUs I'm running there, how many tasks, CPU efficiency, memory efficiency. And what's really important is when I have thousands of these tasks running, very important to be able to go through and track, particularly if there's an error, maybe find out exactly what's happening. So let's find a particular sample, let's say our wild type replicate 2 sample, and I want to know exactly what happened when we ran, for example, star align or fastqc or trim galore. I can select that sample. I can see the exact command which got run here. This is, in this case, trim galore. I can see the individual task information, such as the execution time, the resources that it requested. So it ran in this container on this queue, requested 2 CPUs, 6 gigs of memory in 6 hours. It ended up running on AWS batch, and you can see the cost that was there for that. I can even jump into the individual execution log here. So depending if this creates some output, you can see here the actual output of that. And this is quite useful because typically that will be deep in some bucket, and making that accessible and have a record of that is kind of key if we want to move these technologies forward into the clinic and making them really traceable here. I'm going to show you some pipelines that are completed. Once a pipeline has run successfully, it's possible to get some reporting out of that. So let's go to another one over here. If I look at the reports here, you can see that I can have a PDF report, maybe something that comes out of the pipeline. In this case, they're looking at some DSEC2, so comparing those samples and seeing how similar they are. Multi-QC is another piece of software from Sakara, open source software, which is widely used here. You can see the individual samples and get information on how they've gone through those tools, and then get some, for example, here we've got some warnings which have come up, and making that accessible to folks, as well as just simple structured data, TSV files, and the like. Once I've launched a pipeline once, as I mentioned before, there's cost savings, also got this ability to optimize these pipelines. So I could, for example, optimize this pipeline, and it will define for me how much memory, how much CPU should I actually use the next time I launch this. In this case, significant savings for doing that as well. I'll kind of finally finish off, and this has very much been the user case, but what if you are a pipeline developer? How can you make these available to other folks in your lab if you're developing these pipelines, or really someone who manages the infrastructure? Well, there's 2 parts to that. The first is just simply the addition of a pipeline to this workspace. As a structure, a little bit like GitHub, you can see there's an organization and a workspace. I can simply go into those workspaces. They have different permissions, different roles inside of those, so the role-based access is key here. If I want to add a pipeline, I can simply add the Git repository. So here I can provide it with a name. I'm just going to go to NF Core now. So NF Core is this collection of pipelines which are available. I'm going to take this CRISPR-seq pipeline, given the kind of the nature of the talk. I'm going to select this, paste this inside of here. And I want you to watch this little blue circle here. What we're doing there is we're going to GitHub. We're pulling the code now into Tower. And we're going to check what versions of it are available, what branches, what commits. And let's say that we want to run a specific version where we've got this master or extract UMIs here. And really from there, that allows me to fully reproduce exactly what was in that pipeline. So I keep this kind of full reproducibility built in. But beyond that, I could also then launch that pipeline in different environments. I want you to notice here you can see I'm running with an AWS in Ireland, and you can see we've got this S3 path here. So that's where the intermediate files will be. If I jump and switch this up, if I switch to say, actually, I want to run this in Azure, you can see that now in the case, I've got an Azure bucket there. Or likewise, if I want to run it in my Slurm cluster. So it provides the single pane of glass, which provides all of the flexibility that's required to run these pipelines in a reproducible way. How is that driven? Well, a lot of that's driven from the concept of these computer environments themselves. So you can create as many computer environments as you like inside of each of these workspaces. A computer environment literally just ties into some compute. You can see here that we've got support for the cloud managed services, the batch services, so Amazon Batch, Azure Batch, Google Cloud Batch, as well as some of the schedulers primarily used for on-prem deployments, as well as Kubernetes, which we start to see some traction in with regards to some of those use cases as well. As I mentioned before, there is things like credential management. So for accessing your cloud credentials, your Git credentials, your code credentials, etc., can be added into here. Secret management, participant management, define the roles that folks have within inside of each of those. And I finally should point out that all of this can be driven from API as well. So if you have, for example, you want to trigger the execution of a pipeline based on a Git commit, this is possible. So this is more of a CI/CD workload, as well as if you was to connect Tower in with other resources. So if I hit this endpoint, it will result in the execution of a pipeline based on the parameters which I provide here. So all of this I've shown you again from the UI can be driven primarily also from the CLI, which is available, as well as an API, which is the same API we use for the front end of that as well. So with that, I'll close out this webinar. Super looking forward to some of your questions, and thanks so much for the time.
Grigoriy, Evan, what a great presentation. Those were very clear examples of using Nextflow to overcome challenges in the data analysis workflow. Thanks so much for sharing all of that with us. And we have some great questions coming in, so we'll just jump right into it. So Evan, I think that this one's for you. So how do you deploy and manage Tower infrastructure?
Yeah, it's a really good question. So Tower itself, and I think Grigoriy was showing this, it really connects in with the customer's own AWS environment or other cloud environment. What it enables you to do then is really connect with those services. I think the example that Grigoriy showed there, where he was using other services to link in with Tower via the API. What this enables you to do is really allow you to deploy the whole infrastructure. So that can either be Tower itself, but also the Nextflow pipelines, the computer environments where all of that runs in your own environment. Alternatively, and what I was showing before in the demo was showing Tower Cloud, which is a hosted version, which in this case, you can think of the control plane runs in the cloud that you can connect into, and then you can connect in your own infrastructure as well. Obviously, as part of Secura, we help you in terms of the deployment of that, in terms of the setup of all of those pieces, and obviously provide support for the whole thing. It provides a lot of flexibility for folks. There's obviously a lot of concerns that people have with regards to how they set this up in a secure manner. It's something that we help clients with to make sure they're successful.
Okay, great. Thanks so much for that. Grigoriy, I think that I'm going to ask you to answer this one, which is, what are your use cases for having multiple batch compute environments?
Yeah, sure. So there are different use cases. One of the most common ones is that, for example, sometimes you need to have Nextflow head jobs executing on machines with different amounts of CPU or memory provided. For example, if you are running Nextflow pipeline with a lot of processes in parallel, you would need to allocate more memory to your Nextflow head job. And for this, you would need to have another compute environment, which is able to provide that. And another use case which we have is where your Nextflow's working directory is located, because by default, we use working directory on S3. And it means that between process executions, all the outputs are written to S3 location. And then when the next process spins up, it would download this data onto its EBS drive. But sometimes when the amounts of data are large, EBS drive size is not enough, and the computer environment, the EC2 instance, would have the EBS autoscale script, which would try to automatically increase the size of the volume, but sometimes it's not fast enough and your pipeline would fail. So we would just need to use the bigger like file system. And in this case, we use EFS drives, EFS file system or FSX for Lustre file system as a Nextflow working directory, so that we are not constrained by the size of EBS volumes. And this is the other use case for having separate compute environments.
Okay, terrific. And I just want to remind the audience one more time, if you have any questions for Evan and Grigoriy, to please just put them into the Q&A section of the Zoom. Okay, so moving on, Evan, I'm going to ask you, or
I can add actually a little bit onto
actually, that's what I was
yeah.
just wondering. Yeah, if you wanted to jump into that one as well. Perfect.
Yeah, absolutely. So some of the use cases we see for having multiple computer environments, I guess you can kind of think about the computer environment as a way where essentially you've got obviously the EC2 or the instances itself. What it enables you to do though, by having multiple computer environments, you could have, for example, one computer environment for test, or from dev, or which allows you to essentially have replication of everything, so you can test the whole system out from end to end. The other really important thing is it allows you to really move your workload to where the data is. So you could have different computer environments, which may be in different regions, or as I say, with different accounts. And that allows you to then essentially move the workload. In this case, it's an Nextflow pipeline, but it's typically that code itself to where the data is. It saves having to move the data around specifically for that. And that just provides a lot of savings for folks when they run that, and just simplifies things a lot.
Okay, perfect. All right, thanks for adding on to that. And Evan, I'm going to stay with you for a moment and ask, are you constrained by the type of pipelines you can write in Nextflow? For example, only life sciences?
Yeah, it's interesting. We're starting to see, obviously, Nextflow being used more broadly. I think some of the more crazy things we've seen it for recently is in things like high energy particle physics, so very kind of more batch workloads. Anywhere where there's that kind of high throughput piece where you need to essentially be able to have the jobs distributed and do parallelization at that level. The other, I guess, really obvious use cases where it's almost bleeding out from genomics into other areas, for example, is in imaging. So where there's a lot of imaging taking place, maybe outside of omics work, but more into things like neuroimaging. And again, anywhere there's like batch computation taking place on that imaging. The other one that we're seeing a lot of, and again, a bit of a crossover coming from life sciences, is in machine learning. And a lot of machine learning workloads obviously exist in life sciences for a long time, but the workloads themselves are typically requiring pretty, sometimes exotic hardware. So you're using things like requiring GPUs. You're setting these things up. It's very similar, though, to how you would set up a genomics pipeline. You have a series of steps. You typically are linking those steps together. Those steps needing to spin up resources. Like Grigoriy was showing there, was spinning up the computer environments that you'd be spinning up resources with VMs with GPUs attached to them, and in some cases it's very much the same. So it's definitely, Nextflow comes from a history of genomics in particular, and in itself it's kind of stretching out. Just on the NF core pipelines I mentioned briefly. So those pipelines, there's about 60 or so of those now. And many of those, they are essentially becoming much more broader in their use cases. So I think there's lots more to see in this space.
Okay, terrific. And do you feel, is there a shift in the usage of NCore pipelines toward the cloud?
Yeah, the NF core pipelines themselves, I mean, they're written by a whole host of people from the community. I would say that traditionally, if we look at for example, the Nextflow survey, which comes out every year, we just published a recent version, which came out this week. If we look at that, there has definitely been a shift towards cloud. I would say that the folks who are, Nextflow is still primarily being used by a lot of academics, and in that case, they're often working in HPC environments. So this shift to cloud is taking place. it's more pronounced for sure in a biotech, in an industry, particularly in smaller biotechs who are setting up this ability to spin up your resources on demand to really have a kind of a low overall cost footprint with regards to those resources, which kind of drives that adoption of cloud. The pipelines themselves, though, they're agnostic, and I think this is the beauty of Nextflow. It's completely independent. The workflow code is completely independent of how they run. Now, of course, there's lots of optimizations which can be done, and you can sort of have to think a little bit about the unit of compute that you're running when you're running in the cloud. But a lot of those optimizations are taking place, and if we consider some of the really highly used pipelines, things like NF-core, RNA-seq, it's followed by about 600 stars on GitHub. They've really been truly kind of tried and tested in production across not just AWS, but all of the cloud providers, as well as things like Kubernetes and the other executors. So definitely a shift, and it's a kind of an evolution of those pipelines as they become, I guess, more of kind of a gold standard for running bioinformatics. Right.
Yeah. And do you think that the community NF-core pipelines will stay open source?
Yeah, absolutely. I mean, this is absolutely for sure. I would point out that Nextflow itself is open source, so the underlying runtime it's a Apache 2.0 license, so anyone's free to take it, to use it, to modify it how they wish. The other, I guess, the thing that was really enabled by Nextflow is more beyond the open source, but kind of open science, and the idea that these pipelines, they enable people to share analysis independent of the platform that they run on. So by the pipelines also being open source, this means that folks can take them, they can reuse them. We have customers who take the NF-core pipelines and essentially maybe add their own modifications, and obviously highly welcome when those changes are pushed back up to the upstream. From that, though, the fact that people can take those pipelines, run them wherever they are, means that you can get a whole bunch of people, like domain experts, working on the same pipeline, people who know a lot about a particular program or particular analysis or a particular data type, and from there you kind of get that domain expertise, which kind of feeds back through to the community. So obviously everyone benefits from.
Okay, and Evan, we have a question coming in about the cost and licensing structure. So I'm going to ask you, if somebody has a follow-up question of that nature, is there a way that they could get that information from Sakara Labs?
Yeah, absolutely. If you head over to Sakara Labs, you'll find information on Tower as well as information with regards to that. I would point out that if you want to try Tower Cloud, you can log in today, give it a go. And run it from there. And I guess that the main ways that we have that, as I mentioned before, with regards to the deployment, so folks can try out Tower Cloud. It's a great way to kick the tires and get things going there. And then kind of beyond that, if you want, there's also what we call Tower Enterprise, which is the full installation in your own environment. So those models are both open to you.
Okay, perfect. All right, thanks so much for that. Well, thank you for that, Evan and Grigoriy. And with that, we've come to the end of our webinar today. So I'd like to remind everyone that this webinar will be archived on the Gen website. That's at genengnews.com for up to a year. So if you missed any parts of it, you can watch it again, or feel free to forward it to any of your friends and colleagues who you think might be interested in this content or the webinar itself. I'd like to again thank Evan and Grigoriy again for this incredibly informative presentation. And I'd like to thank you, the audience, for your attention and the thoughtful questions. As always, a very special thanks goes to the Gen production team for everything running so smoothly, and Sakara Labs for sponsoring this webinar. Hopefully, we'll see you again at another Gen webinar in the near future. Goodbye for now.